Okay. And what kind of programming languages are you comfortable with?
Well, C, C++, and Python. I have done my course on machine learning and deep learning as well.
Okay. And how do you rate yourself in C, C++, and Python on a scale of 1 to 10?
Well, I find myself more comfortable with Python and then C with a lesser node. But yes, I can code on that, and I don't have much of that good grip with C++. So I'm comfortable with C and Python. And if I'm supposed to rate myself from 0 to 10, then I would say that 7 might be a good score because I'm not into that much of competitive programming, but I know a bit of it.
No, individually, can you rate C, C++, Python?
Okay, sir. For C, I would say 6 will be better. Will be good. And for C++, 5 somewhat, and for Python 7.
Okay. All right. Cool. All right. So now I'm going to let Abir and Nilay continue with the questions from the technical side.
Okay.
Yeah, yes, Sandeepan. I'm
Yes.
audible.
Yes, sir. You're audible completely.
So you told like you have an electrical background, right?
Yes.
Yeah. So are you kind of like the electrical guys who are much more into coding, or you're much more into circuit designing?
Well, I'm much more into circuit designing, the hardware part.
So what non hardware platforms you have explored?
You mean as in the field of my electrical engineering or in the field of quantum computing?
Both, you say, let's say both.
Well, if you ask me about quantum computing, I have just begun and I have been working on this IBM Qiskit. And if you ask me about the electrical engineering project which I have done, then I have worked on three research based projects, and I actually am the third one is like my major project which is going on. I'm drafting my report. So one project is based on nano and based on basically nanotechnology, which uses the chemical elements of bay leaf, or we call it as Eglem amulose, which is used for designing a mobile phone cover, which will help reduce the radiation emitted from the mobile phones. So this is the first one, and the second one being I have worked on spacecraft propulsion or electric propulsion, as you say, as in particular. Actually, I was working on a project on nano satellite from my university. I am from KIIT, Kalinga Institute of Industrial Institute and Industrial Technology, Bhubaneswar. Under that project, I designed a thruster, which is now being on a filed for a patent. And the third one, which is
You
my
designed a
signed for a patent, designed a
no.
thruster, pulse plasma thruster.
Okay.
Okay, yeah, the two projects, this one and the previous one I have mentioned, these both are now filed for a patent application from
So they
my
are
side of
working
my.
hardwares.
Yes, no, actually, yes, they are both hardware. So like the one is a mobile phone cover, which is a particular, which is supposed to be a hardware prototype, and the other one is a thruster. So yeah, it is obvious that a thruster design is not that much possible in a hardware laboratory, and I have designed it in a simulation during this pandemic last year,
Okay.
and the
So
third.
what all softwares you know? Like, have you explored various controllers, microprocessors?
Yes, I have. I have just completed my course on Texas Instruments MSP 430, which is the embedded systems. I know Arduino. And apart
So
from
MSP 430, which coding platform you used?
yeah, the Code Composer Studio.
Okay. So have you worked with FPGAs?
Yes, I have worked with FPGAs. I have this knowledge. I have done an internship on SOC verification, and I have gone through Verilog, System Verilog, and UVM.
Okay. So you are very aware of different types of modeling in Verilog, right?
Yes.
Yeah. So how do you think we can use FPGAs in quantum?
Well, as far as I see, as far as I have realized and come to know about FPGAs, that FPGAs actually work faster than the ASICs, can work faster than the ASICs, because like they can operate on two tasks on a parallel
Yeah, that's clear. But the question
base.
is, how do we work around Like you told you're aware with different, like there are different modelings, right? Gate level, structure level, data flow
Yes,
level.
behavioral
Yeah.
level. If you talk about Verilog, there are two kinds of modeling. One is gate level and the other one is
Yeah, yeah.
behavioral
So
level.
how can we use FPGAs like in
Well,
quantum hardware?
well, I would say that if we are to think of let's say designing hardware for particular transmission, or let's say any monitoring purpose, then FPGAs could work in hand. For example, let's say if you have to connect this system via IoT, or if we have to do the edge computing as this is followed in Industry 4.0, FPGAs come in good hand because they are faster and they will be efficient in higher data or baud rates as we consider, and higher data processing and higher what should I say, uh, depth, as in say in asynchronous C4, and plus
Okay, so
in
you use
faster speed.
Xilinx platform or
No,
something
sir.
else?
Actually, I haven't. Sir, if you are referring to the FPG development hardware platform, and I am referring to the coding. I mean, sir, if I have to like if I am supposed to divide this thing, you are referring to the platform which is now developed. Now I am referring to the part which is like the coding we do, and then which is transformed into the basic that level which converts the protocol. Let's say if we am designing an AMB API protocol. So the coding, the basic gate level coding is done on that basis. So I have learned that part basically, which is technically called a system on chip. So like my internship as an intern, my role was for in design verification. So I know that part in a much
Where did
I
you
should say
intern?
better. Science Semiconductors, which is in Bangalore.
Okay, yeah. Abir, you can take one.
Yeah, hi Sandeepa.
Hello, sir.
So you told that you have experience with some languages, so maybe C, C++, and Python.
Yes.
So I'll just show you some code snippets from C language. Can you please just tell me the output, what it will be?
Okay.
Is my screen visible?
Yes, it is completely visible.
So this is the code, and you have to tell me whether the variables res1 and res2 would be equal or different, and if they're different, what will they be?
Okay, sir. Let me see. It will take me some time for a while.
Yeah, sure. Don't take too much time though.
Okay, sir. Just no, not
There
that
are
much,
other
sir. I'm
people
for
also
sure.
in the lines. Yeah.
Okay, sir. No, rest one and rest two won't be equal actually.
Okay, why so?
Okay, sir. Wait. Okay, if you see result one, which is I plus and j plus plus multiplied by plus plus I, which is like the I is now bitwise shifted to a one, like right shift, and then minus plus plus then j is again bitwise shifted. And if I to see, oh sorry, sir, that's a mistake. Actually, both are equal. Actually, I just could not see the syntax actually, and I was following the board math. So result one and result one are two are both same. Since the operation are same, that I and J have been through this bitwise right shift, and then they multiplied and then subtracted through this bitwise J. So the result one and result two will be equal.
So plus plus operator is bitwise shifting, right shift.
Yeah, well, if it is before the variable, then it is.
Hmm. Okay, and if it's after the
And if it
variable,
is after the variable, then we are just adding it plus one. Like if it is j plus plus, then the value will be j plus one. And if it is plus plus I, which means we are just bitwise shifting with uh, plus one. So
okay.
like the value will be different. Not will be not will be I plus one, but will be
Okay.
different.
Okay. Okay. You have also worked pretty extensively in electronics, so I would ask you one more question on this. So this is a bit string that I have. Okay.
Okay,
You might
sir.
have worked with microcontrollers and like the bit operations, bit manipulations in your internship. So I have this bit string, And finally, I want to make this particular bit string. So basically, you have 1010 from here in this bit string.
Probably for folks that maybe aren't as familiar with.
Um, yeah. So you have 1010 here in the bit string, and you need to extract this 1010 and make a bit string something like this. So can you tell me the sequence of operations that will follow for this?
Well, I'm not sure about this, but I really think this will be a Mealy model. So the sequencer.
Not a finite state machine. I'm asking
Okay, sir.
like in terms of C code, right shift, left shift, or AND operation. What transformations you will do to the
Okay,
first
so
bit string to the second one?
okay, so the operations are supposed to be on the first one, right?
Yeah.
Okay. Well, I believe I'm not much sure about the answer, but I really think that there is a need for a right shift so that we could get over this. And I guess this is supposed to be this bit stream is supposed to be right shift by one times, and this is or and by the initial bit. So I guess we can get this one. I'm really not sure about this.
Okay. Okay. Fine. Other than this, can you please tell again what all softwares have you used for quantum? Like only Qiskit or
Only
are
Qiskit,
there
sir.
any other?
Actually, I'm just now entering into this field in a
Hmm.
full-fledged manner. Since it is my last semester, so I will be active from May. My exams will be my exams will be over by 7th of May, which means now that gives me free space to completely work on full-fledged manner. So,
Okay.
before that, I have begun. I have started working on IBM Qiskit, and I'm using Anaconda, and I have installed Qiskit and coding basic quantum gates. I haven't started with multiple qubits yet,
Okay.
and
Okay.
I'm looking for expansion of my skills in this field. So, and hence I have filled this strawberry field in the Google form, so
Okay.
that I could learn this part of quantum annealing as
Okay.
well.
One last.
Oh, sorry, photonic systems as
One
well.
last question. Why did you specifically choose
Yes, sir.
photonics?
Sir, actually, I was interested in photonics for once. I wanted to study this, but then when I got to know about this quantum computing and the other principles, and the principles followed in quantum computers, the
Hmm.
one being superconducting qubit, the other one is photonic one, which is followed by Xanadu, and then quantum annealing, and then nuclear magnetic resonance, and BEC this and much more. So I thought that since photonics is somewhat which could help me with the study the light shifts and the various aspects. So then why lagging behind when one can get to learn more through practical opportunity, more feasible manner?
Okay. Okay. Fine. I think I'm done from my side. So,
All right, great. Cool. Sandeep, we'll be updating you by this weekend over email. So look forward to that. Okay. All right. Any other questions you have for us?
Not as such, sir. But my question is that what is the aim of this group, or what the aim of this project which we are now interviewed for? Like, what are the uh, research, and what will be the outcome which is expected throughout this?
So it can be two things. One is a research paper, and the other thing is a POC from a hardware standpoint.
So hardware based, which will be the hardware based, like the superconducting qubits or anything else?
Nilay, Abir?
currently, as you might know, that superconducting hardware is the like platform that has open source tools like Qiskit Metal and everything.
Yes, yes,
Uh,
like research one.
so yeah, mostly we'll start with that, but it's not like we'll focus on only one thing.
Okay.
Multiple people can focus on multiple different hardware architectures, and then we can converge to something which is solid and more practical.
Okay. Okay. So I believe that I am done with the question.
All right. Okay.
I'm
Thank you, Sandeep. Have a good night.
thank you.
Hello. Hello.
Hello.
Yeah. Hi. May I know your name?
Yeah, I'm Ramachandran.
All right. Hi, Ramchandran. Can you quickly tell us about yourself and why you're interested in quantum hardware?
Yeah, okay. So, yeah, sure. So, I done my undergraduate in EC and I just worked at ECS for a period of 1 year. So now I'm looking for new opportunities. So I got passionate about quantum computing during my college term itself. So I did basic research work on quantum dot, I mean circuit design, quantum dot subtractor circuit design, which I published in IEEE conference. So after that, I found lately I found IBM Qiskit Summer School, and after that Qubit by Qubit. So I got more involved in quantum computing. So that's about it.
Okay. And what are the programming languages that they're exposed to?
Everything C, C++, Java, and Python.
Okay. And if you have to rate yourself on a scale of 1 to 10 individually, how
Mhm.
would you rate yourself?
Mostly I'm mostly in touch with C++ and Python, so I may say that around 7 or 8 for both.
Okay. All right. Cool.
Yeah.
All right, guys. Abhi, Nilay.
Pardon?
Hey, Ramchandran.
Yeah, hi.
Yeah, so what's your favorite flavor for qubit?
Pardon? What's the flavor?
Like which qubit architecture you like?
Actually, I just the Qiskit workshop taught us basic about superconducting qubits. So I just started with superconducting qubits, but right now I'm just learning about some basics of photonics. So photonic qubit is also okay for me. I just started learning photonics.
Yeah, so can you draw a difference between superconducting and photonics? Like which is advantages over what?
Photonics, I don't have that much idea about that Xanadu's computer, because right now I started to learn about photonics. For superconducting qubits, we just use that instead of using the natural atoms, we use artificial atoms through Josephson junction type material. So they must be
So why
close
do
to.
we use Josephson junction?
Yeah, instead of using that original electrons, which we cannot manipulate that much, we use superconducting artificial atoms.
Yeah, that's correct. But what's the significance of Josephson junction?
You mean, why do we select that for
Yeah,
making
like okay, like can you tell the basic structure of superconducting qubit, like the basic circuit?
no, I'm not that much into the details because I didn't find that much of information.
Yeah. Okay. You told you're from EC background, right?
Yes, exactly.
Yeah. So what are the processors family you have worked with?
I worked on previously in my college. I worked on 8051 PIC AVR microcontrollers, Arduino, and Raspberry Pi. The processors, basically, I just worked on 8086 during my college, and recently I just done normal 8-bit breadboard like computer. So it's just 8-bit and a simulator for that.
Yeah. So have you studied about like Hamiltonian mechanics and all in physics?
It's long back, so I don't remember most of it because I studied in first year. So after that, I didn't get that much into it.
Okay. Yeah. Abir?
Yeah. Hi.
Hello. Yeah.
So, can you tell me what all quantum algorithms you're aware of, or have you studied any of them?
Yeah. Recently, first I started with the super dense coding, quantum teleportation, Joshua, and there's something. Zinani's best, but I mean, I'm not sure about the full best thing something. Zinani's algorithm and Schwartz. I just recently learned this.
Okay, so can you tell me one common thing that goes for Deutsch-Jozsa, Bernstein-Vazirani, and other like oracular algorithms? What is the basic principle on which they work?
In Shores, yeah, basically in Shores, we first use quantum
Not
Fourier
sure.
transform.
I'm asking about Deutsch-Jozsa, Bernstein-Vazirani, and let's say Grover's algorithm.
I mean, Grover's, I really just started with it, but I haven't completed it. So
Okay,
in Vazirani's algorithm, yeah. In Vazirani's algorithm, we use first Hadamard gate to make it into a superposition of all state. It's basically like a period finding, but not in continuous signals. It's finding the string value to which if you give an input of x and suppose you apply a unknown string, say for 110 to x to the function of x.
Let me pause you there.
Yeah.
So my question was not to explain the algorithm. It was what is one common thing which happens both in Deutsch-Jozsa and Bernstein-Vazirani? Any similarities that you see, or any phenomenon that occurs similarly in both the algorithms?
Deutsch-Jozsa. Okay, I can't remember that much on Deutsch-Jozsa circuit itself. Yeah.
Currently, what all languages are you familiar with? And are you good with coding?
C, C++, Java, and Python.
Okay. So if I ask you to rate yourself in all the 4 languages out of 10, can you?
Yeah, mostly I'm currently in touch with C++ and Python, so I'll rate around 7 or 8.
Okay.
For both.
Okay, and C and Java?
C, I mean, it's similar to C++, so it's around 7, but Java, I just need to brush up on that because I worked on web development during my final year, so I just need to brush on that.
Okay. So you are familiar with the basics of quantum mechanics, right? The like Hadamard gates and
yeah,
rotational gates and all those things. So I have a question for you. Can you see my screen?
Yeah. Sure.
So this is a pseudocode which is written. Okay, so you can see we have defined a single qubit in the Q register, and there is a function test which is getting implemented on that. This is a function test. So we implement RY gate with pi by 2 as the parameter, and we have the Hadamard gate after that. So can you tell me what will be the output of this particular pseudocode? Like after you measure the qubit, what state we will get? And if there are multiple states, you can tell probability of each state.
Just a second, I'll just draw the box here. 0, 1, and you rotate by it is Z. Rotate 0, rotate by 2. So
Try to answer it a bit quickly.
oh, sorry. Okay, then so if I rotate, I just got only one confusion. So
You can speak also while thinking. I want to know your thought process as well. So
yeah, I just top one is Z axis. So if I rotate 0 by 90 degree, I get plus state. So 1 by root 2 0 plus 1 by root 2 1. If you apply a Hadamard, it will go back to the 0th state. Yeah, as far I understand from this.
Okay, okay. I have one more question for you of similar type. This time we have 2 qubits, and this is a C0 gate. So
C naught, it's a Bell state. Okay.
Okay. Okay. Fine. Yeah. Yeah, I think.
Sure. Yeah. All right. Cool. Thanks, Ramchandra.
Yeah. Thank you.
All right. So do you have any questions for us? If not, we'll be sending a mail by this weekend. Okay.
Actually, I just want to know what is this program all about. Just I saw that Qiskit Metal tutorial hardware, so just I joined. So what is this? How will this structure?
So we'll send you a landing page. Okay, you can read over there. Ideally, you should have done that before applying.
Okay. I just saw quantum hardware and then just I tried
Yeah, I mean,
because I
yeah,
previously wanted to know
I
that
mean,
quantum. Yeah.
yeah, I get it, but you can also think from our side, right? We can't sit and say the same
Okay.
thing to 30
Okay.
people, right? That's the reason why we
Yes.
have put up a landing page, right? Huh.
Okay.
All right, so
Okay.
we mail you,
Yeah.
you can have a look at that. Basically, it's like peer learning. We're learning from each other, and we're learning towards an output. So either we'll be coming out with research papers by comparing different platforms or optimizing errors and whatnot. Or the other thing is come out with POCs. That's the output from this learning circle. Okay.
Okay. Sure.
All right.
Okay.
Thank you. Have a good day.
Thank you. Yes.
Cool. Next is Praveen, right? Sorry, it's not connected. Hey, Avinash, are you here for quantum machine learning? Avinash? Cool. So Praveen, can you quickly give a brief about yourself and why quantum hardware?
You meant by quantum hardware?
Are you traveling?
No, Moses.
A lot of disturbance on your side. We can't hear you properly.
Is it any better now?
Yeah, much better.
Okay. So yeah, I thought you asked like why quantum hardware. Is that right?
Yeah, but like first a quick brief about yourself and then why quantum hardware.
Okay. I'm basically from Kerala. Like I'm working in Ernst & Young as a machine learning engineer. I did the Qiskit Global Summer School last year, and ever since then I've been part of learning quantum computing and organizing talks in my organization. And we have recently collaborated, like tied up with Microsoft to work on a use case, an industry specific use case. So like I said, like I'm very keen to explore the field and learn.
All right. And what kind of quantum platforms that you're exposed to?
I have used IBM Quantum Experience Portal. Also tried D-Wave platform.
Okay. All right. Cool. And what are the programming languages that you know?
I've worked on VB.NET in the past, but nowadays mostly Python.
Okay. All right. Cool. So Abhi Nilay.
Hey Praveen.
Hi, Nilay.
Yeah. So could you tell us about like what's your background like? Are you like the CS guy or you like some other branch and then later pursuing CS?
Yeah, so I did my engineering in Tripoli, like electrical
Okay.
and electronics. Yeah,
Yeah. So I guess you would have like you have a touch on electrical stuff right now or like it's dusted.
that's it.
Yeah.
Um,
So moving on, like you said, you had worked with D-Wave, right? Like the Ocean SDK.
D-Wave, yeah, explored. You,
Yeah.
yeah.
Yeah. So can you tell us about like why, like what's quantum engineering?
Okay, so one of the basic difference that I found was that IBM was basically gate driven, and whereas D-Wave used this annealing. So the property means like annealing in itself means that you heat something to some extent and then allow it to cool in a controlled manner, so that during that process you are in a much better position to control the properties of the particles or elements within it. So with this is the principle I believe D-Wave is using for their operation.
Yeah. So like we generally get a energy landscape, right, as an outcome.
Yeah, right. Yeah, they do mention that. Yeah.
Yeah. So what do we exactly look on the energy landscape?
I'm not sure about the terminology, but I think
Yeah,
one of the
like we try to find some local, global, and all, right? Like something like that.
okay, yeah, there will be local minima and global minima. Basically, we will be trying to measure the energy level. Uh, the lowest or global minima can be used for optimization problems, and uh, local minima along with global minima can be used for sampling related problems, I guess.
Yeah. So like the D-Wave use was like, is it like sort of project related or just out of curiosity?
And D-Wave was out of curiosity, so does it goes with the IBM,
Like,
but
so what did you implement there?
okay, nothing specific like um, one thing we tried or like which something which is in progress is that we are trying to build a simple representation of a hybrid neural network in D-Wave. So basically, there was one use case which was done in IBM platform, wherein we add a single qubit layer into a classical neural network. So that single qubit does both, forward and backward propagation. That one we are trying to, um, sorry, we are about to tell something.
Yeah, cool. Yeah, Abir.
I didn't get this. Sorry.
Okay. So actually, I would continue on the thing which Nilay was asking. So can you tell me like what kind of problems is IBM system good for, and what kind of problems is D-Wave system good for?
Okay. So IBM's, since it's like gate based, I believe uh, the more number of qubits we add, the more unstable the system may become. Like, or I'm not sure if that's going to improve drastically anytime in the future. So both can be used for optimization problems.
Okay.
Uh, the volume of data might be a
Can
thing
you
to
speak
address.
a bit louder, please? It's a bit.
Yeah, as far as I know, I think both can be used for solving optimization related problems.
Okay. And is there something that D-Wave system can't do that IBM system can? And if you know the reason why it can do that.
Uh, let me think about it once again. No, I'm not quite sure about that.
Okay.
There, yeah.
Okay. So you told that you have used some of the quantum computing platforms like Qiskit and everything. So can I tell you a simple circuit, and can you tell me the output of uh, the circuit when we measure it?
Okay.
Yeah.
A simple circuit. Maybe I will take the NOT gate.
No, I mean, I'll tell you the circuit. You tell me the output. I meant that. So the circuit is something like this. Listen carefully. You have Hadamard gate on the 0th qubit, and then you have one CNOT gate from the 0th qubit to the first qubit, and then another CNOT gate from 0th qubit to second qubit. So what will be the output that I'll get in this particular circuit?
So let me. So on first qubit, you have first the Hadamard gate, followed
Hadamard
by
gate, yeah.
then on the same 0th qubit, you have the CNOT gate, right?
Yeah, CNOT gate. So target is 0, and my bad. The control qubit is 0 for the first CNOT gate, and the target qubit is 1. For the second CNOT gate, the control qubit is 0 and target qubit is 2.
So totally 3 qubits, right?
Correct, yeah, 3 qubits.
The second CNOT control is first and the target is second, right?
No, the control is 0 and target is 2.
Okay, from top.
You can
Okay,
write it down if you want to.
yeah, I just drew it. And, so you want me to give the output of
Yeah, yeah.
so when we apply Hadamard gate, we will get a superposition of 0 and 1.
Okay. Please try to do it a bit fast.
Yeah, sure, yeah.
Oh, thanks.
I think it's 0, like all
Okay.
with 100% over. Yeah,
So all
Okay.
qubits will be 0 when we measure it.
yeah, that's what I think. Yeah.
Okay, okay. Fine. I think I'm done. So Sam, please.
All right, cool. Thanks, Heads. Praveen, do you have any questions for us?
So one question, like I thought this was about forming a learning group or something.
Correct.
What was that?
Yeah, so it's forming a learning group, but like focused towards an outcome, could be a research paper or a small POC,
Okay, that's great. Yeah.
right? Yeah. So if you have no other questions, we are done with the interview. We will be sending a mail by this weekend about the next steps. Okay.
Sure, yeah. That sounds great. Thanks, most.
All right. Thank you.
Thanks, Nilay. Bye.
He's good.
Looks
Hafiz
diligent.
was Is it say correct? The answers?
I don't know. I mean, the answers are not correct. I think he needs to brush up the basics.
Okay. Hmm. Hey, Akash, can you hear us? No. No. Akash? No. Yeah.
Should I?
Hi, Akash. My name is Moses. I have Abir and Nilay here. We'll be conducting a interview right now. So quickly, can you tell us about yourself, your background, what all you have learned, and why you're interested in quantum hardware?
So my name is Akash Sarkar, and I live actually in Kolkata, but my hometown is Palashi, Nadia, and graduated my I graduated from Calcutta University, and my subject is on mathematics honors, and currently I am doing my MSc or postgraduate in data science in University of Kolani, and I quantum computing. I want to learn quantum computing because I think this is the future of our computing system and the various things, and uh, that's why.
Okay. What's your exposure to quantum computing? Have you worked on Qiskit or any platforms related to quantum?
Uh, Sorry, sir. The sound is a little bit low, actually.
Have you worked on anything related to quantum till now? Any platforms?
Yes, sir. I am currently doing IBM Qubit by Qubit Introduction to Quantum Computing, sponsored by IBM. I am doing that course. This is my semester 2, and I used a little bit of Python to make circuit or IBM. I have a experience of something IBM quantum experience.
All right. Okay. And what are the programming languages that you're exposed to?
I learned R, Python, and C.
R, Python, and C. Okay, cool. All right. Abir, Nilay, take it over.
Hey Akash.
Yes.
Yeah.
Sir.
So you told you have come like you have a mathematics background, right? Statistics, mathematics.
Yeah,
Yeah.
my graduation background is mathematics.
Yeah. So do you have ideas about basic electronics?
Electronics, a little bit, sir, because sir, in class 12 or in HS, I learned physics, and there are past subjects or general subjects in my honors, and the past subjects are physics and chemistry.
Okay. So you know about basics, electrical laws, right? Ohm's law and all.
Ohm's law.
Yeah.
Yeah, sir, I know, but currently, I mean, I cannot tell you this right at this time.
Yeah, but like you're aware about those like Kirchhoff's current law, Kirchhoff's voltage law.
Yeah, I read all that, but due to I mean due to some gap is there, so
Yeah, like I understand that like you have a mathematics background. So yeah, so being like given a chance in the team, like where you have two options, either you become the person who codes or you are the one person who develops the mathematics of the system. Like suppose we want to suppose like the entire quantum mechanics is basically mathematics, right? Like you write the laws, like you write the equations and solve the Hamiltonians and all and other things. So which one would you prefer? Like solving the maths and adding the skill which you have into this, or you will be the person who will want to code?
Sir, I want to code.
So you don't like doing the math?
Sorry, sir.
Like, so you don't like doing the math?
No, sir. Actually, I like doing the math because, but sir, the coding is also a mathematical approach or logic. So I think, and I think this at this time I would like to code.
Yeah. So are you aware of state space model?
Sorry, sir. Actually, sound is a little bit low, so
Yeah.
that's why.
Are you aware of state space model?
State space.
Yeah.
State space.
State
Hello?
space model.
Yeah.
Yeah. Can you tell something about it?
Uh,
Like,
I'm.
yeah. Okay. Tell.
So state space means model is something like that. I mean, I cannot tell so much briefly or like something. Yeah, I can tell you just an idea that my quantum system in which state it was is now, and that is the actually the state space model, or which in I mean in which space I want to my quantum system to have, and that is my state space model.
No, not in regards to quantum. Like it's a mathematical approach. Like suppose we have given circuits, control systems coming in. When we have very big control systems like which come along with very big circuits, we can't sit down and find the current flowing in each branch or something. So we convert the entire control systems into matrices, and then we do the maths of it. So that's state space. Yeah. Good. Abir?
Yeah. Hi, Akash.
Hello, sir.
So I think you mentioned that you have been doing your postgraduate in data science.
Yes, sir.
So I am assuming you have adequate knowledge for slight coding.
Yes, sir.
Okay. Just a sec. Give me a second. Yeah. So I'm going to show you an equation. Okay. Can you tell me if you can translate this to whatever language, let's say Python, if you're comfortable in? You need to convert this particular summation equation into Python code. So how will you proceed for that?
Sir, here we have to use two for loops.
Okay. So can you tell me what all will be the parameters for those for loops, like the range of for loops?
At the first for loop, we use I equals to 0, where I less than n and I plus, and in under that for loop, we'll use z equals to, for z equals to 0 and less where z less than equals to m and z plus, and after that we will do xij for x.
And if I if I do that, if I tell that j is always less than I here, okay, so I add one more condition here, that j is always less than I. Okay, so how will you make changes to the code to have that particular thing?
J is always less than I.
Yeah. Like which for loop will you make changes to, and what changes will you make?
In for then I think, sir, then we have to put j less than equals to I in second for loop constant. I mean parameter.
Okay. Okay. Fine. Yeah.
Thank you, sir.
Okay. One more thing. So, are you familiar with C codes?
Yes, sir.
Okay. So there is one more thing. I'll just share my screen again. And I hope you're able to see my screen.
Yes, sir.
Yeah, so this is a small code snippet that we have. And can you tell me what will be the value of the res variable when I get the output?
So I think, sir, the value will be 4.
4. Okay. Can you explain me how it will be 4?
Sir, there is I, and this is we take it as a variable at first int I equals to 1, and there are after that is, sir, I plus plus, that means, sir, post increment, and the plus I that means, sir, pre increment, and that's why in post increment it simply means that we if we take a variable, and the whole program should run, and after that it will be increment to +1, and pre-increment is nothing but opposites of pre-increment. I'm sorry, post-increment.
Okay. Fine. Also, you have studied some basics of quantum computing, right?
Sorry, sir.
You have studied some basics of quantum computing, right? In
Yes,
the qubit by qubit thing.
yes, sir.
So, can you tell me what is the use of T gate? T for tomato, T gate. What is the use of T gate?
T-gate.
Yeah, T for tomato.
Oh, sorry, sir. I don't know.
Okay. Do you know about S gate?
No, sir.
Okay. Do you know about Hadamard gate?
Yes, sir. Hadamard gate is actually used to equal superposition, to give a qubit to equal superposition.
What if I don't want to give an equal superposition? What can I use in that?
Sorry, sir.
If I don't want to give equal superposition, let's say I want a superposition of 60-40 for getting 0 and 1. So which gate can I use? What type of gate, or which specific gate can I use for that?
64. Sorry, sir.
Okay, no issues. Yeah, thank you, and yeah, I'm done.
All right, cool. Cool. Akash, thanks a lot for joining. We will keep you posted by this weekend about the next steps. Okay.
Yes, sir.
Meanwhile, do you have any questions for us, Akash?
No, sir.
No? Okay, cool. Lovely. Thank you. Have a good night.
Thank you, sir. Good night.
All right.